HanselMinutes.com. It's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan, announcing show number 191, recorded live Thursday, December 3rd, 2009. Support for Hansel Minutes is provided by Telerik RAD Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.telerik.com. In this episode, Scott talks with Nathan Brixius with the Solver Foundation team.
Hi, this is Scott Hanselman, and this is another episode of Hansel Minutes, and I'm on campus at Microsoft here in Redmond, Washington, wandering around the halls and talking to lots of interesting people, and I'm actually sitting down here with Nathan Brixius with the Solver Foundation team. That sounds like a really complicated team. The Solver Foundation team. What is the Solver Foundation team?
So the Solver Foundation team has been around for a few years, and we had our first release last year. What we are is basically a .NET platform for modeling and solving like planning, scheduling, and optimization problems. Mm-hmm. So we build a library that .NET programmers can use to model and solve optimization problems. Okay.
So what is an optimization problem?
Well, you find them all over the place, actually. There's lots of interesting examples. For example, suppose you are an investor and you're trying to take your money and spread it across some different investments in a way that will give you a nice return but not be too risky. That's an example of an optimization problem. You have a goal in mind, but you also have some constraints that you're operating under. Another one might be maybe you're scheduling a conference, or maybe you're scheduling your classes at school. It's another example. You have some goals in mind, maybe not to get up too early or to have your classes run consecutively, and also some constraints, like you can't go to two classes at the same time, for example. Mm-hmm. So you find optimization problems in finance and in scheduling. Like there are many supply chain problems, for example. You're trying to get products from place to place at low cost and so on.
Is the classic traveling salesman problem a optimization problem?
Yeah, absolutely. That's a classic example of actually a difficult optimization problem. There's many different kinds. Some optimization problems are solved pretty easily, and there are others, like the traveling salesman problem, where the number of possible solutions blows up exponentially with the number of cities in the problem, and so you have to resort to some pretty heavy-duty techniques to find solutions to those sorts of problems. Mm-hmm.
So, with all due respect to your team, it's probably fair to say that the chances of the listener having heard of this library is probably low. Would you say that this is not a mainstream, kind of like bump into a .NET developer on the street? Hey, yeah, you checking out the Solver Foundation stuff? Oh, yeah, totally.
Yeah, exactly. It's we're a new team, we're up and coming, and it is something that traditionally in the past optimization has kind of been hidden away from the general public, in part because it's been pretty hard to get your hands on and pretty difficult to actually use in a real live production applications. One of our goals is to try to make it more accessible for people.
So then I would take it even farther to say, is it fair to say that the average .NET developer doesn't know about your library and your group, but they very likely have one of these problems, and they may not even realize it?
Absolutely.
And they may have been solving it with just a series of for loops and magic.
Absolutely. Yeah, programmers come across these problems all the time, and as you say, many times what you do is maybe you will just dream up something on the spot, or maybe you'll do a little search, or maybe you'll crack open your one of your textbooks from college, one of your algorithms textbooks or something, and dig in there. But of course, that's not what we do for many other tasks that we have as programmers, like sorting. Most of us, hopefully, if we need to sort some numbers, we're not going to go and try to write our own sorting algorithm. We're going to understand that there are libraries out there that help us to do that, and they've been well tested and so on. We go to that. So what our goal is to try to make these really powerful tools accessible to people. And it takes time to sort of build up, education about what it is that we're doing, and also to help people to understand the ways in which this could be used, because it is very broadly applicable.
Okay. So this is something that I download, and it's a series of in-proc DLLs?
That's right. In fact, it's one. So you can go to solverfoundation.com, and there's a free Express edition, which has all the functionality. So you can download it. It's a managed code DLL. So for example, if you're a C# programmer, you can add a reference to the Solver Foundation DLL into your project.
Okay.
And then you can follow along with the samples that get downloaded as well, and then start, trying it out, building some models and solving them.
Okay. So building some models and solving. So that was kind of my next question.
Yeah.
This is a group that creates this with this one DLL. So it must be complicated. I mean, it must be a lot of magic in there, and it must scale from very small basic samples up to pretty intense. Could you do even multi-machine solves?
That's actually a great question. Right now, you can't do multi-machine solves. I mean, we won't do it for you.
Right, you'd have to chop it up yourself.
You have to chop it up yourself. But what we do right now is use all of the cores, all the processors on your machine. So if you have a problem which is, particularly difficult, based on Solver Foundation, we'll do an analysis of the problem and chop it up into pieces and use all of the processors on your machine to solve it. And that's something that even someone who maybe knows a lot about the algorithms and the solution techniques, they might not know how to do that analysis and make use of all the computational power on the machine. As you know, these days, pretty much any machine that you'll pick up these days has several cores. So that's important.
I mean, it's fairly trivial to spin up a background thread, right? And when people think about multiprocessing, they might think, well, yeah, I've got this and I've got my background thread.
Yeah.
But even with something like the new parallel extensions and the stuff that, Stephen Tobin, those guys are doing around PFX, still even if I knew the algorithm and I understood parallel extensions, it would still be non-trivial to go and write a multi-core solver.
Exactly.
So what kind of data structures am I creating? Is this a declarative model where I describe the problem in a series of data structures and then hand it to you?
That's exactly right. It's our focus. What we want users of Solver Foundation to be able to do is just think about what their problem is rather than how to solve it. So it is a declarative framework. And so the representation of the problem that you want to solve in Solver Foundation is called a model. And so the model has just a few building blocks. So it has, for example, a goal. I described some goals earlier. For example, find a minimum risk investment portfolio.
I think that's a good example we can use to walk people through this.
So there's an example of a goal. And that's the thing it could be a business objective.
How do I describe that? I mean, it's easy to say in prose, but how do I describe a goal like minimum risk in code?
Got it. Well, what Solver Foundation offers is basically a toolbox in an expression language that lets you define these. Mm-hmm. And so define these goals essentially, mathematically or algebraically. So you could, in the example we're talking about, if it's a minimum risk portfolio, I might want to look at the risk associated, the correlation between two different types of investments. So like stocks and bonds. And I might want to multiply those sort of risk factors with the amount of money that I've decided to allocate to a particular investment category. And so if I, like for example, 30% of my money I might want to allocate to bonds. Okay. And so I multiply that with these risk factors and I add them all up, and that gives me an expression which represents the total amount of risk in the portfolio. Okay. So Solver Foundation it lets you use this, standard like plus and minus and times and those sorts of things, and as well as adding some additional constructs that let you combine these building blocks into goals.
So thinking, and forgive me if I'm speaking to you as I'm more like a 4-year-old or 5-year-old here, but trying to get down to the basics of this. Is this like when I was doing algebra and doing multivariable solving, where it's like, yeah, it's easy to solve for x. Now solve for x, y, and z, where you're trying to minimize z.
Right.
Whereas is that an example?
That is definitely that's an example.
Okay.
And
so I've got a series of goals that I want to meet, and in my x, y, z example, I really want to solve for something that meets a goal with some constraints. So it's not just about finding a goal, but it's about finding the goal within the constraints. And is it those constraints that make the problem difficult? Because I want the listener to understand, like the ones that are still awake at this point, because we're talking math, right?
Yeah.
That this is hard because to find the optimum is the goal.
That's right. That there are. It's extremely complicated, but that's absolutely. It's true to say that when you combine the goals with having to, meet some of these constraints, you have you can oftentimes have a very difficult problem. I mean, if we could go back to the traveling salesman example.
Maybe for the listeners who may not be familiar with that problem, explain the basics of the traveling salesman problem.
The idea is that there's a salesman who is going out selling products in different cities, like let's say 5 cities, and the salesman wants to drive around to visit each of the 5 cities, but he or she wants to do so. Visit each one of the cities once, but minimize the amount of distance that they're driving.
Right. So they want to hit every city because they're a salesman. They don't want to visit cities twice because that's a waste of gas.
Yep.
And then they've got multiple ways to get to a city because there's multiple roads.
Right.
How do you visit every single city, minimizing the space and the number of trips per city?
Right. So if you break it down, right, the goal is minimize the travel distance. And a constraint, we just listed
don't visit a city twice.
Can't visit a city twice. Need to visit every city at once.
Seems simple.
Seems simple. And you can, basically, if you write down that prose description of the problem, you can sort of underline, here's a constraint, here's a goal, and so on. Each one of those components is not too difficult to understand.
Right.
Now you put it all together and you try to say, now what's the optimal tour? What's the best tour sequence of cities to visit? That is an extremely complicated problem. And that's an interesting example because that's a case where coming up with a solution that meets all of the constraints is really easy, right? I mean, if I say the cities are Atlanta, Boston, Chicago, Dallas.
You can eyeball it.
You can just eyeball it. You can come up with all sorts of solutions.
Right, but now take the traveling salesman problem, and make it a multi-city, 20, 30 city situation where you've got a truck of produce and you've got to get the apples to Dallas before they rot.
Exactly.
Then things get a little more interesting.
Exactly.
Okay, now is that the kind of thing that you're trying to solve?
Absolutely. And so the way, I think the beauty of what we're offering with Solver Foundation is you can say you start with a traveling salesman problem and you're able to list out the goals and the constraints and so on. Well, now you can add more constraints to the problem. For example, the produce.
Okay, so once you've described the model correctly, so if I understand correctly, the model I would describe would be the graph of all the potential connections between these different cities.
Right.
That's the declaration of the map, in this case, a graph of paths, and then the weights of those paths indicating travel distance and things like that. And then the constraints are the rules that we just described. I can add on my own custom rules later. I can run the problem multiple times with different rules.
That's right. With different rules, or with different data. Because the way you would describe the traveling salesman problem in Solver Foundation, say that we started with 5 cities, a simple problem. Well, in Solver Foundation, there's a for each expression. So you could say for each city, and then an expression which says visit the city exactly once. Right. So that doesn't depend, that expression doesn't depend on there being 5 cities.
Right.
So I can scale up the problem size, use different data, larger data sets, for example, and my model doesn't change. And just as you said, I can now add new constraints or change the constraints or change my goal. and I don't have to, it's a much simpler process. I don't have to start from scratch.
Hey everybody, this is Scott coming at you from another place and time. No doubt you probably bump into testing tasks now and then in your work. And you know, writing functional tests is probably not your favorite thing. It's kind of difficult, takes time, and the results can be dubious. Well, get ready to start liking tests thanks to Telerik with the new WebI testing framework. Building web automation tests is a breeze. You've got code automation with advanced ASP.NET Ajax and Silverlight applications. You can write a single test, have it executed against multiple browsers at once. You benefit from a rich API. There's link support, integration with Visual Studio unit testing, also NUnit, XUnit, and MBUnit. Not to mention the free wrappers for Telerik RAD controls for ASP.NET Ajax and Silverlight, all shipping with Telerik's new testing tool. One of the best features, the WebI testing framework, which is developed by Art of Test, is it's absolutely free. If you've already got hooked on WebI testing framework, start using it right away. Go to Telerik.com for more info. Thanks a lot. Okay, so three questions just popped into my head, and they'll kind of all make sense because they're all related. With Solver Foundation at the hub, I'm visualizing data coming in, data going out, and then data in the form of constraints kind of coming in the middle. And I'm wondering, in what formats can I bring this data in, and how am I doing that? Like if I've got, a million records of something that's in a database that represents some model, and then I've got, I want to make this accessible to my business users, so I want to plug them into maybe Excel or some UI of some kind. They're going to describe some constraints, and then I want the result to come out as a PDF.
Right.
How far does Solver Foundation stretch in each of these directions versus just letting .NET and the various libraries that I have available do that work for me?
Got it. So at the very top, I said Solver Foundation was a platform, and
that's a big word for a single DLL.
It's a big word for a single DLL. What we want to do is let .NET do what it does well, and we're not in the business, for example, of writing out PDF files or reading from databases. What we want to use, we want to take advantage of all the other good stuff within .NET to allow you to do that. So what we do in Solver Foundation is we have a set of data binding APIs and interfaces that you can use. So for example, if you have a database that you want to read your data from, you can use whatever technique you like in .NET. For example, you could use some link expressions to bring down the data and bind it directly.
I asked the question a little bit selfishly because before I worked at Microsoft, I worked in banking.
Yeah.
All of our data lived in mainframes.
Yeah.
And we would do bill payment things, and we had a thing that was called least cost routing, which I'm starting to realize that we solved a problem that we could have actually kind of done a little coding by subtraction, which would mean deleting our stuff and using your stuff. Yeah. Least cost routing is I've got a bunch of banks and I've got a bunch of payments and a bunch of people want to pay a bunch of other people. I have relationships with some banks. It costs me this much to pay that guy via you or via Swift or via this.
Yeah.
Least cost routing is the act of paying all of the different bills to all the different people via all the different banks, given all of their different prices in the way that would cost people the least amount of money. And we charged people bajillions, that's the official term, of dollars for the feature that is least cost routing. And sounds like a classic Solver Foundation problem.
It is absolutely a classic problem. And
I had to call those guys because I don't work there anymore.
Well, and it's funny because you find this over and over again in many different industries.
I didn't recognize it though.
Yeah, exactly. And that's the pro and the con of working on a team like Solver Foundation is we are building something which is very general purpose. And so one of the challenges that we have as a team is to really have good examples and good case studies and things so that give people the inspiration, help people understand all the different ways that this could be used.
How do you get the word out though? I mean, there's not a foundation Solver Foundation rather, evangelist.
No, I guess I'm as close as you get, right?
But you're a dev, right?
Yeah. I write code. I'm passionate about, optimization and this stuff. And, I do want to see people using it. We don't have, TV ads. We don't do.
Well, and do you charge for it?
We do. There's an express version. There's a standard version and there's an enterprise version. And, the difference between the three is, and the express version, which is free, we do cap the problem size. So you wouldn't be able to put a million constraints in your problem.
Okay, I wouldn't be able to solve my bill payment thing without paying somebody.
Exactly. Nor would you be able to redistribute it in an application because, like we talked about before, it's just a DLL. And so you could imagine this working in an ASP.NET application or a Silverlight application or a
I can use it anywhere?
Absolutely. You can,
wait a second. So I can run this in Silverlight?
You can, not within
Don't
the
tease
Silverlight.
me now.
Well, what you could do is write a backing WCF web service.
Okay. But this runs on it runs on the desktop CLR.
Correct.
So I can run it in ASP.NET or WinForms or WPF or whatever. Yeah. Yes. Which actually brings up a very interesting question. All this time we're sitting here talking about managed code, but isn't optimization problems and these kinds of solutions typically solved in C++?
Typically they have been. That's right. And Solver Foundation is the first purely managed code .NET solution for these sorts of problems. Mm-hmm. So no one's really ever tried that before, and there were some doubts as to whether the performance would be
right. Well, surely it must be slower.
It is quite competitive.
Really?
Actually, yeah.
So competitive is another. I'm not speaking for the Solver Foundation team, but competitive is code in Microsoft for not slower.
So I have to be careful about it just because we don't benchmark and so on. But
it's not like 10 times slower.
No. And we are solving really large scale industrial strength.
Really? Can you give a sense of how big the data sets that you can work with are?
So I threw the term million constraints around.
Oh, you weren't kidding.
And I wasn't kidding. Okay. There are real problems that Solver Foundation is solving right now that involve millions of constraints.
And do I need millions of processors and millions of megabytes of memory?
You don't need millions. You need I need
a beefy machine.
You need a beefy machine, but we're talking about a single multi-proc machine with a lot of memory, but
like a lot, more. like a 64-bit, like 8 gigs kind of a thing?
Yeah.
Is this typically a thing I would want to do with a 64-bit, with, a .NET app that is compiled for 64-bit?
Not
Do I need more than 2 gigs?
No, you don't. Of course it depends on the size of the problem, but, I routinely, I have my laptop, it's a nice laptop, but it's nothing too special, and, I have no problems running models on that.
So back to the point about C++ and C#. As I understand it, you've been in this space of optimization problems for a number of years. You probably must have coded these before .NET. And what languages did you use before?
Yeah, this is what I did before I came to Microsoft, and I was a Unix guy and a Linux guy. I did a lot of coding on Solaris and HP machines and a bit of Linux, and and the languages of choice were Fortran, C, and C++. Mm-hmm. And so I'd written solvers before I came to Microsoft. And then once I came in the Solver Foundation team, it was, switching over to C#. And so I've had quite a bit of experience trying to solve the same sorts of problems, but using different languages. Mm-hmm.
And does the language get in your way, or is this because all of these are kind of C-style languages? Do you think about that? There's a lot of talk about things like Erlang and different languages that are not classic C-style languages. Can I use F# in the?
Yeah, absolutely. In fact, so a couple things. One is that there's a lot of people in the financial industry, like quantitative analysts and so on, who really love F#. Mm-hmm. And we're finding a lot of interest from people who want to use F# and Solver Foundation. And so, in fact, one of the samples that we ship is an F# sample.
Cool. So it's totally appropriate to do that.
Oh, absolutely.
And I don't have to see any C# to do it.
No. You can use the .NET language of your choice, and there are plenty of F# samples and VB.NET samples and so on.
So what are kind of some of the pros and cons that you found in writing Solver Foundation in C# versus writing it in C++? Because I kind of feel like in an old school Microsoft, maybe a couple of years ago, they might have forced you to write it in C++ and done an interop layer.
Right.
But it sounds like there was some kind of a tiny victory or a big victory maybe when you guys convinced the powers that be to do this thing managed. And right?
Right.
Is that true?
Absolutely. That is true. And it's really been the conventional wisdom within, this has been actually a long running argument that even predates C#. So
Really?
if you go back 20 years ago, there were people who were saying C++ is too slow. You need to do it in Fortran because of the way you can, because of array access and so on and so forth. So as time goes on, there's always the same sorts of arguments, but the languages change. C#, I mean, I have to say, I love writing Solver Foundation code in C#.
Okay.
The argument that you will get is really the performance argument. People will say, with managed code, with C#, because of, compiling it into IL, because of the garbage collection, because of the fact that you're not coding as close to the machine as you are in C++, that you will never be able to have an acceptable level of performance, or you'll never be fast enough. I mean,
Right.
that's the primary, argument that is made. And, there is an essential truth to that.
I mean, there is more stuff going on.
Yeah, there are, for example, there are array bounds checks that happen, and all sort. There are things
automatically
that you have no control over in C#, which you don't need to do.
Well, if you know how big your array is.
If you know how big your array is, and you do everything correctly, you don't need to do in C++. And with the type of code that I'm writing, it is very, computationally intense. There are lots of tight for loops where you're doing, you're adding, multiplying, dividing numbers and so on.
Right. And because you're floating up at this higher layer of abstraction, I mean, even though C# and C and C++ look like similar languages, fundamentally there's several layers between you and the metal.
That's right.
And you're effectively a business logic programmer.
Right.
Even though you're doing intense computational stuff.
Yeah.
And the CLR is there to provide you comfort. And the comfort it provides you is via, silent bounds checking and automatic garbage collection.
Right.
And when you're in a tight loop or deep in a series of tight loops, wouldn't you wish that you could just turn it off? Like, wouldn't you want to put a block, like the unsafe block or something, and just say, don't worry about it, I got this for a minute, and eke out that extra 3% or that extra 4% of performance? Or do you just not worry about that kind of stuff?
Well, I guess
what I'm trying to understand is your philosophy around micro-optimization. I mean,
my philosophy is that you really need to take a more holistic view, a more top-level view of the problem.
Okay.
Because there are sections of the code where there are these tight for loops, and in those particular sections, as you're writing them, you might say to yourself, I wish I could just go unsafe and skip these length checks and so on. But what you need to take a step back and think about how users are using this code. Like we're just a couple minutes ago, we were talking about expressing these constraints and these goals and so on in a declarative language and so on. And there's a lot of steps that need to occur to solve a problem, right? So you need to get the data, you need to do some pre-processing and analysis of the problem. And then, so these loops that you're staring at when you're writing code, they may seem extremely important at the time, but what you really need to do is go back and measure and see what the real impact is. And what we have found is that if you write good, solid, careful managed code, and you're thinking about performance as you're writing the C# code, the difference is not, generally speaking, not that great in the when you look at the total system performance.
I think the trick is that programmer type, I'll make a generalization here, that the kind of personality that makes an excellent programmer is almost sometimes the kind that overthinks things. So like you just said, and if you think carefully about performance, and I thought to myself, and if you overthink appropriately about performance. It's like, when do you stop? At what point do you back off? And I think you've made points to me before, the idea that you could fight for that last 2% and then lose it on a single disk write.
Yes. Yeah, that's absolutely the case. It's hundreds of times more. I don't know the exact numbers, but it's hundreds of times
billions
more.
And billions.
Billions and billions of times slower.
But yeah, it's a big deal. I mean, we're talking about you fight for that 100 milliseconds and you lose it because somebody swapped you to a different core or whatever.
Right. So I think a key is to understand how this piece of code is functioning in the larger system and measure and measure on the scenarios that matter. And you need to have some goals in mind. How fast does it need to be, right?
Yeah, exactly.
And you stop if you don't have a goal and your goal is just make it faster, well then you'll never be done, right? And we all want our code to run as fast as possible, if nothing else, just as a point of pride, right? But we don't have, there's only so many hours in the day, and you need to just establish some goals of like, well, how fast does this need to be? Otherwise, you'll never get anywhere.
Is profiling a big part of what you guys do? I mean, is that like fundamental to the way you guys write code? It
is. I mean, there's a couple of things we do. And so the first thing is we think about what our goals are. We think about the scenarios, and we regularly just measure the performance.
Okay.
Like stopwatch time without a profiler, just to make sure, because sometimes very innocent little things can.
Oh, really? So when you say stopwatch your time, you're not kidding. You're like saying, this series of tests should run in 2 seconds, and suddenly we made a change, it runs in 4.
Yeah.
So you're saying you're actually measuring that. Do you have like constraints set up in a continuous integration system such that it would fail and you would be alerted?
Yes, every night. Actually, our testing team is fantastic. Every night, thousands of models and test cases run, and we measure the performance and we compare it to a baseline, and these red flags pop up if the performance degrades too much.
Okay, so performance regression is a real problem, and something that you have quality gates to figure that stuff out.
Yes.
You would think that that a solver foundation would be the classic test-driven development example.
Yeah.
Do you guys practice that here? Do you like write models and say, I know the solution to this?
Yes. Oh, absolutely.
So red-green testing, red-green refactor.
And I think it's so easy to want to jump ahead because you're so eager, but many times what I will do and other people on the team will do is we'll actually take a very small problem and write it down on paper and actually solve it out. Yes.
Paper.
It's made of wood. You just work out the numbers and that can be a very first test case.
Yeah.
And then you can, build up slightly larger examples and so on. Just start very simple. And in general, I would say when you're thinking about performance or trying to evaluate whether I should be using C++ or C# or something, it's good to just get in the habit of writing very small, simple test programs that, sort of be a scientist, try to come up with a hypothesis and measure.
But they've got to be valid tests, because I think that sometimes you always see those examples that get thrown around the blogs every once in a while. Someone takes a language and they take another language and they say, and I spun in a million loops and 4i equals 1 to a million, and that's completely inappropriate. I mean, it doesn't make any sense at all. It tells you that it can do a loop.
Exactly. So the key is nobody knows more about the scenario that you're trying to address with your code than you, the programmer. So learn to sort of distill the essence of what you're trying to do and write a small, representative program that makes sense for you, the particular project that you're working on. Just sketch it out.
Right. Solve it once and then solve it n times later.
Yeah. Yeah. I mean, and don't rely on someone else's
measurement.
Measurement, right? Do your own measurement.
I like that.
What they're measuring may not.
Don't rely on anyone else's ruler.
Yeah.
Yeah. Measure twice, code once.
Absolutely. And it's much easier to write that kind of basically throwaway code. Just sketch it out. There's so many fewer things you need to worry about. You just need to get the right pieces in there and get it working and get a sense.
Mm-hmm.
It doesn't need to be down to the millisecond exactly reflective of how it will be in your real production code. It needs to be fair and close,
So where can people go again? You said it was solverfoundation.com, and that'll
That's right.
redirect us somewhere?
solverfoundation.com. There's a little front door website, and there's a download link, and that will take you to our MSDN site where you can go and grab the download.
Very cool. Well, thank you so much, Nathan Brixius, for chatting with me today about Solver Foundation and optimization.
Yeah, thank you. My pleasure.
This has been another episode of Hansel Minutes, and we'll see you again next week.